Good morning, friends. Our today's topic is the properties of fluid. Now, in that, we'll see density or mass density. The second one, that is specific weight. Or weight density. And the third one, that is specific gravity. So, we'll see the density that is denoted by rho. Weight density is denoted by small w, and specific gravity is denoted by g. Now notations may change books to book. Now we'll see one by one what is density or mass density. So that is the ratio of mass divided by volume. Now mass means mass of fluid in that volume. So first of all, we'll see the units. Unit of mass is kg and volume is meter cube. So again, if we elaborate these things, we'll see by an example. Suppose for water. Now we'll see what is density in terms of water. If there is a box of dimension 1 meter by 1 meter by 1 meter, means the total volume of the box is 1 m cube, and in this 1 m cube volume of box, if we pour the water, if we take the weight of this box, it is approximately 1000 kg. In this the water is there. In this 1000 kg, that is the weight divided by of what? Of 1 m cube volume. So we are saying that density of water is equal to 1000 kg per m cube. So this is the way how we can analyze the things. Now if we think for the mercury, suppose for mercury, what happened? The same box now will take, having the dimension 1 meter by 1 meter by 1 meter. Now in this box, again same 1 m cube box, but in this box if we take the mercury, and if we again weight the second box, that is of mercury, you'll get the answer, that is 13600 kg of same volume 1 m cube. Why this happen? So this is because of the density, Now we are saying density of mercury is equal to 13600 kg per mq. Further, if we take the third example for steel, instead of mercury, if we take the steel, now the value, that is weight, again increases and you will get the higher density. Means if weight increases, the density of material increases. So we can understand like this or analyze the things like this. Now the second is specific weight or weight density. See the difference between mass density and weight density. Here the mass is there and here weight is there. So difference between mass and weight, mass is constant everywhere, whether it is on earth or on the other planets, mass is constant, and weight varies with acceleration due to gravity. So the formula for weight density goes like this: weight divided by, this is mass divided by volume, now this one is weight divided by volume. And if weight is related on acceleration due to gravity, that means it can be measured in newtons also. Why? Because force is equal to mass into acceleration, so that is the unit of force. Or we may also say it as weight is a type of force, so newton per meter cube, that is the unit. If we again expand this thing, weight is what? Mass multiplied by acceleration due to gravity divided by, weight is mass into acceleration divided by volume. If we separate out mass divided by volume, that is nothing but mass by volume is density, that is rho, multiplied by acceleration due to gravity, we may write it as g. So we are having the formula, that is small w specific weight is equal to rho multiplied by g, specific weight. Now how to calculate the specific weight? Again we'll take the same example for water. Now we are calculating specific weight of water is equal to rho multiplied by g. So density of water is how much? 1000. 1000 multiplied by 9.81, and the unit is, this is weight density, so unit of weight density is newton per meter. Now again for second, that is B, for mercury. If we calculating weight density for mercury, formula is same, rho multiplied by g, always considering g in weight density. So density of mercury is how much? 13600. So 13600 multiplied by 9.81, and unit is newton per mq. In this way we can calculate the specific weight or weight density. Now come to the third point, that is specific gravity or weight. Specific gravity, that is denoted by g. So you are having the specific gravity is nothing but weight density of any fluid divided by, we'll take any fluid, divided by weight density of standard So in this case, standard fluid is water. So what is weight density of water? We know that 1000 kg per m cube. Now, if we see the unit for specific gravity, weight density divided by weight density means unitless, no unit. So this is no unit. Now, if we are calculating specific gravity for any material or any substance, like again we'll take the same option, that is A, for water. What is the specific gravity for water? So for in the formula, weight density of any fluid, now we are taking water. So weight density of water is how much? So that is, weight density means rho multiplied by G. We know that. So weight density of water is here 1000 multiplied by 9.81 divided by weight density of standard water. So standard fluid, in the denominator we have taken water, that is always standard, and this is the density, that is 1000, but we want weight density, so 1000 multiplied by 9.81. So again the ratio is same, 9.81. So both the term get cancelled and you'll get the specific gravity of water, that is 1. In the same way, if we are calculating specific gravity for mercury, G m is equal to, so weight density of any fluid means now mercury. So mercury is having weight density 13600 multiplied by 9.81 divided by weight density of standard fluid, always standard, that is 1000. So 1000 multiplied by 9.81, because this is density and we need weight density, so multiplied by 9.81. So 9.81, 9.81 get cancelled, this double zero get cancelled, and you'll get the value 13.6, that is the specific gravity of mercury. So from this value you may calculate this specific gravity. Basically, why we need specific gravity? To calculate the weight density of any material. That is the basic reason behind knowing this specific gravity.